So we have a couple questions here. We need to come up with quadratic polynomials that fit a given situation. So let's start with this first one. And I already have the vertex form of a quadratic function written right here. This is going to help us come up with that equation that we need. So I'm going to start off by writing y equals. And let's look for the first thing we have to get. It says that we need to open up wider than the parent function. So the parent function is y equals x squared. And to get this to open up bigger, we need to change the value of a. So to do that, we need a value of a between 0 and 1. As long as it's between 0 and 1, that parabola is going to open up wider. So let's say that this is the parent function here, and if we pick an a value between 0 and 1, that parabola is going to open up a little bit wider. So let's go ahead and just use 1/2. That's right between 0 and 1. Okay, now I'm going to start by writing the part in parentheses. So we're going to have x, and now h is the x value of our vertex. So that's going to change how far to the left or to the right we go. So if we look in our equation, it's saying that we need to shift to the right 4 units. So the vertex is going to have an h value of 4. And then k is going to be matched up with the y value of our vertex, and it looks like we need to shift down 2 units. So if our y value is going to be going downwards 2 units, we're going to have a -2 for the y. So now back to my equation here, I want to take this 4 for h and plug it in right there. So I have x minus h, and if 4 is h, then we're going to have x minus 4. So I write that down, and we write x minus 4 squared. And if you're saying, well, wait, we have a positive 4, why are we subtracting 4? Well, remember, in this formula we're subtracting, so we want to do the opposite sign of what we have here. So that's why it looks like it's a -4. Okay, so now at the end we want to add in our k value, and our k value is -2, so we want to add in a -2. Let's just say we're going to subtract 2, so we could use the exact sign there. And this is going to be the polynomial that represents this situation. Okay, we want to do the same exact thing for the second question. And I'm going to continue using my vertex form of a parabola. So let's start with y equals. And the difference with this question is that it opens narrower. So instead of picking a value that was between 0 and 1 for a, we're going to need a value that is greater than 1. So I could do 2, 3, 4, 5, 6, anything that's bigger than 1, that's going to work. So let's just go ahead and write down a 2. And then I'm going to continue with what I need to put in parentheses. So it's going to be x. And now let's figure out what that vertex is going to be. It looks like we're shifting it to the left 3 units. So if we're going to the left, my x value for h is going to be -3, and then we're going up 1 unit, so the k value, which is the y value, is going to be +1 or +1. So that's my vertex. Now if I take this h value and I plug it in for h here, that means that we're going to have x minus our h value, and like I just said, our h value is -3, so I would plug that in. Now since we're subtracting a negative number, that's going to be the same thing as adding that number. So we could write x plus 3, and we're squaring that quantity. Now if you want to go and show this stuff, that's fine. Or remember, when we're subtracting, it means we're going to do the opposite sign of whatever we're given. So if you see we have a negative and you know that we have to go opposite, you could just write in +3 here. And then lastly, our k is added at the end. That was 1, so we're just going to do +1. And this is going to be the polynomial equation that represents what's happening in this situation. And actually, let's go back real quick to that the horizontal compression. I didn't talk about that, but imagine that we have our parent function here, right? That's going to be the y equals x squared, and we wanted to have a horizontal compression. That means that we want to push this parabola kind of closer together, and that's the whole making it narrower. So imagine if this is the vertex and we're pushing these sides in closer together. By multiplying this quantity by 2, it means that our parabola is going to be kind of like skinnier, right? Or more narrow. So that's what a horizontal compression is. Back in that other example that we had, a horizontal stretch would be pushing outwards. So that's why in my last example I had a parabola that was actually a little bit wider. And that's when you multiply this quantity here by a number between 0 and 1. I think we picked 1/2, but that's a little bit more information about these.